Hey guys, what's up and welcome back to another video of Geeked on Science. So this is a continuation for our series that we've been learning about the periodic table of elements. And today, as you can see, we're going to be learning one last group, the group 7 halogens, which as you can see are fluorine, chlorine, bromine, iodine, astatine, and tennessine. So if you're excited for this video, smash the like button. Without further ado, let's get right on into it. So, if you are new to this series, definitely go watch them in the link in the description. But if you are new, we always start by learning the location of these specific elements so we know how their physical and chemical properties react. So, let's not break tradition and start with their location. So the halogens are nonmetals which are located in group 7 of the periodic table. Now group 7 is the scientific way to call it. However, many people, since they consider there to be 18 groups in the periodic table, call the group 7 halogens group 17 halogens. You can call it however you want, but I would recommend you to call it the scientific version because it's more accurate. And there are actually 6 elements that are the group 7 halogens. Now that we know the location, we can effectively and accurately identify their physical properties. Let's start with their physique at room temperature. So chlorine is a green gas at room temperature, with a bromine being a brown liquid. And iodine is a purple/black solid at room temperature. Now keep in mind these are at room temperature with no reactions. Now let's learn about their melting and boiling points. Since melting and boiling points for group 7 halogens are complicated, I'm going to explain it to you in a simple way. Group 7 halogens are diatomic molecules, and this means that their atoms come in pairs all the time. And this means that their atoms are joined by a covalent bond. And as the atoms are joined by a covalent bond, when you move down the group, the melting and boiling points increase as the intermolecular sizes increase. Now, when the increase in size happens, the intermolecular forces, or the negative energy of the atom, becomes stronger. And ultimately, more thermal energy is required to overcome these forces at a greater temperature, causing melting and boiling points to be higher the further down you go the group 7 halogens. Now, before we move on to the chemical properties, I just wanted to tell you that we will not be discussing astatine and tennessine in this video because they are radioactive elements and it's a lot harder to understand them, and we'll be going over that in a specific video when we're covering radioactive elements. So now that we have that out of the way, let's learn about their chemical properties. Now, just like they have 2 physical properties, group 7 halogens have 2 negative ions, or 2 chemical properties. Negative ions and producing salts. Now, producing salts is caused by negative ions, so let's understand negative ions first. When group 7 elements react, they all have 7 elements in their outer shell, and since all elements want to be stable to have a full valence electron outer shell, this gives them all similar properties. So when group 7 elements react, they want to become a negatively charged ion, meaning that they have to gain an electron, and since ions of group 7 halogens always have a full outer shell of electrons, they gain an anion, aka negative ions. Now, this negative ions produces the salts, but how is the question? When halogens react with metals to produce the salts consist of ions held by ionic bonds. And it's easy to remember this because ion and ion are in the same word. And ions are always held by ionic bonds. And chlorine here, if we take an example, reacts vigorously with the metal iron that's heated. And since salt consists of ions, the anions that are given to the electron in the ion, this might be a bit hard to follow, but the anions are given to the electron in the ion are held together in the salt with ionic bonds, meaning that the negative ions transfer over during the ionic differential proposition when the elements react. So, when chlorine here reacts vigorously with a metal iron when heated, the word equation for this is salt iron chloride. Now, iron plus chlorine equals iron chloride, but to make the salt, it's salt iron chloride. However, as you can see, the number is the same. Now let's look at the reactions with a metal observations. So fluorine is a cold iron and it burns to produce the white iron 3 fluoride. Hot iron wool with chlorine burns vigorously to produce orange/brown iron 3 chloride. And the numbers there are just to signify where on the periodic table the element is of the ion. Next, let's learn about bromine. Hot iron wool quickly burns to produce red/brown iron bromide. As you can see, all the ions, or fluorine, chlorine, bromine, and iodine, become fluoride, chloride, bromide, and iodide. That's just a wording thing. It doesn't really mean much unless you consider the reactivity of them. Now here's where it gets interesting. Iodine reacts slowly because it's a vapor. Now vapors react slowly, and the iodine vapor reacts slowly to produce the gray iron 2 iodide. As you can see, because it's a vapor, it gets a different number on the iron iodide reaction, 2, instead of the usual 3. Now let's learn about their reactions with hydrogen. Fluorine explodes at room temperature to form hydrogen fluoride. Chlorine explodes in sunlight or with a flame to form hydrogen chloride. Bromine does not explode but has a vigorous reaction to form hydrogen bromide. Iodine, again, a very slow reaction when heated with hydrogen iodide. Now, all those hydrogen iodide, hydrogen bromide, hydrogen fluoride, and hydrogen chloride, those are all the reacted elements of halogens. Those are called halide compounds, hydrogen halide compounds. When chlorine, fluorine, bromine, and iodine, or the group 7 halogens, react with hydrogen, they form hydrogen halide compounds. And the word equation for this is hydrogen plus chlorine equals hydrogen chloride. So hydrogen halides are specifically gases which dissolve in aqueous solutions to form your acidic solutions. An example of this would be hydrogen chloride dissolving in water as an aqueous solution base to form hydrochloric acid, which is an acidic solution. Now let's learn about their trends in reactivity. So when the group 7 elements react, they form the anions that I've talked about, which are negative ions, and this makes them gain in 1 electron. Because it's easier to gain the electron than move the proton, by gaining the electron, they use less energy, thus becoming more stable. And since the atoms become larger as you go down group 7, the outer shell becomes further away. Thus the force of attraction in the outer shell is reduced. And when this happens, the outer electron is gained less easily. So even though the melting and boiling points go up as you go down the group, the halogens go less reactive as you go down the group, because of the amount of space it has between the outer electron and the inner proton. Thank you so much for watching this series, guys. I really appreciate it if you watched until here, and would like it if you like, share, and subscribe my videos. Thank you so much for watching once again, and I really appreciate it. See you in the next one.